Hi, Assalamualaikum warahmatullahi wabarakatuh. I am Amirul Bahari. Today I want to share about software quality metrics. This slide is created based on the two slides that I get from the literature review, which is one of these, and the second one is the software quality metrics. Here, this slide. So, first we move to the learning objective. So basically, the learning objective is the outcome from our learning here. So what you need to take note is the definition, the objective, classification, frameworks, methodology, features, and limitation. You must at least you must understand how each of these produce their output. So by definition from the IEEE, the keyword here is a quantitative measure, not a qualitative, because quantitative is something that we can measure, not the qualitative. Qualitative is like a quality, something that we cannot measure. So the second one is the function of whose input of software, which relate to a numerical value. That are numerical that can be interpreted. So that data can be the output of the data is something that we can measure. Okay. Next, we move to the objective. Basically, the software quality metric is to facilitate the management, control, planning, managerial intervention, more to management of control such as change or anything related to that. And the second one is to identify the preventive or corrective action. This is much more for improvement of the system or the development. Okay, we move to the classification. So there are three classification: product, process, project. But for our learning here, we must focus for product and process. The product describe the characteristic of the product, all anything related to the product, and the process is related to improving software development, maintenance process, more related to the SDLC. Okay, so we move to the framework. Framework is like a blueprint or like a guideline for us in order to create a metric. The first step we can see here is the quality requirement. The first one, we need to understand the requirement, and then the second one, identify the factor, and then the third one is quality sub-factor, and the fourth one is the metric. If you want to easily understand what is factor and sub-factor, you can get back to the previous chapter before, which is quality model. So from that model, you can see there are some model that are major factor and there are minor factor, which can be called like a sub factors. So the methodology by EEE. So the methodology is something what we call like a proper way in defining software quality metric. So the first one, establish. You must understand the keyword establish requirement. So and then identify metrics. The third one to implement the metrics. The fourth one is to analyze the metric result. After we implement, we get the data, and then we need to analyze the metric result. And then the number 5 is to validate the quality metric. Is it okay to use this metric in this scenario? Some of metric cannot be used in other scenario, but some of it can be used general in many scenarios. Okay, so this is good SQ metric, must specific, comprehensive, reliable, understandable. If you if you feel it's hard to memorize this, you can use the SMART, SMART, like how we can define the software requirement. Okay, this is the limitation. Of course, anything there are limitation. So the main limitation of this software quality metric is the budget, human factors, and validity. Budget relate to the resources. If you get low budget, of course the matrix will be not accurate. Human factors is the human error itself, and the validity is the suitability of uh, the metric, whether it is easy to understand or is it too ambiguous. Okay, this is I show here metric example that I get from the literature review. The Albany here, 3 slide. You can take it as a metric for your project. Okay. Okay, next we move to literature review. So the first one is a report on the analysis of metrics and measures on software quality factors. In this paper, there are many metrics provided that have been compiled together for the purpose of the software quality metrics. This is some of the table provided in the paper. So we can dig deeper in this paper. It's from Vanita, International Journal of Computer Science and Information Technology. You can search this paper to get more approach or measurement metrics provided here, so you don't need to create yourself. So one of the table here is about dynamic metrics and quality factor coverage. There are metrics: cohesion, coupling, complexity, polymorphism. This metrics, the measurement technique is we can use polymorphic behavior index for to measure polymorphism. This under quality factor of reusability. Okay, other than that, we can see also object-oriented design metric and quality factors coverage. Besides that, there are also structural and sub-factor quality metrics and quality factor coverage. If you read this paper more, you can see there are formula here. How to measure readability, how to measure reusability. This is a good paper. If you start in to create a quality matrix, you can go to this paper. Okay, next we move to the second paper, which is the goal question metric approach. So the goal question metric approach is an approach on how to step by step on how we can create a software quality matrix. And here I want to show the step, which is okay. There are 3 steps here: conceptual level goal, which is the goal what we want to measure. There are defined here the product, process, or resources. And the second step is operational level, the question. And the third one is the quantitative level, the metric. So as an example, if we say the product, the goal is to search for code, the line of code. So the question is how complex is the system. So the quantity level, the metric here, we can say the complexity of the system is measured through the number of line of code. So that is a example of how we can use this GQM approach to create a metric. Okay, if you want to understand more, there are a lot of other. There are figure, goal 1, question, and then this is the table on how they use some formula such as current average cycle time divided by baseline average cycle times by 100. Okay, that's all from me. Thank you.